I'm going to show you how to create an action figure nightlight. I chose this task because I like electronics and thought it might be a fun learning activity parents couldn't do at home with their kids, or teachers could use in some sort of tech shop. This activity can be a great STEM project. For the sake of time, I'm going to skip over some details, like definitions, calculations, composition of circuits, and electron flow from cathode to anode. But by the end of this project, your child or student will understand how to light an LED. Think of this as a beginner's guide, which you can use as an introduction to electronics. If you have older kids that already have an understanding of electronics and have worked with Arduino, Raspberry Pi, or soldering irons, they can apply their skills to make modifications to this nightlight, such as using a light sensor instead of a switch, a potentiometer to change the brightness, or program a microcontroller to change the color of RGB LEDs. Be creative and be safe. The tools I use in this project are listed in the description, but you can complete this project without all of the items listed. Needle nose pliers, wire cutters, wire stripper, I'll be using a different pair later in this video, and a heat gun. Although there's not enough space to display it here now, you will see it later. A lighter can also be used in place of a heat gun. A battery source with leads that connect to positive and negative terminals. I'll use a case that holds 4 AA batteries, but a 9-volt battery will work too. 1 LED, 1 resistor. This is called a through-hole resistor, and this type specifically is called an axial leaded resistor because the metal legs protrude from each end. I will not cover Ohm's law in this video. You'll need to do a little research to determine the right size resistor for your LED. But in general, you'll be fine using a 330 ohm resistor if your battery source is 9 volts or less, and your LED is rated with a forward voltage of 3 volts and a current rating that can handle a continuous forward current of 20 milliamps. This might simply be listed on the datasheet as a forward current. But in this case, a 330 ohm resistor will provide plenty of resistance. If you choose a resistor that is too small, in other words, it doesn't provide enough resistance, the worst that will happen is your LED will burn out. You won't start a fire, you won't see smoke, the LED simply won't light, and you probably won't even notice the blowout. That's why it's best to buy some spare parts and test your equipment before you begin the final setup. You'll also need 2 strands of heat shrink, some splicing connectors. Since I will not be soldering anything in this project, I will be using 2 connectors by Wago. 2 strands of hookup wire, anywhere between 22 gauge and 30 gauge should work. I'm going to use this 30 gauge wire here. All of the wire I'm using is stranded, but you can use solid wire for this project. 1 action figure with a hand that is slightly open for gripping. I'm going to use Catboy from PJ Masks. Take a moment to look at the wires and heat shrink. The colors of these wires and heat shrink are significant to this project: red, black, and blue. Think of the objects that are red as items that will be connected to positive leads, while objects that are black or blue as items that will be connected to negative leads. I'm going to run through 2 simple tests. Now you don't have to run through these tests, but I'd rather know my parts are working properly before assembling rather than finding out something is broken after everything is assembled. This first test checks whether the LED works. It can be done with a simple coin cell battery. This one is a CR2032, the kind that you'd find in a digital watch. LEDs have 2 legs. One will be longer than the other. The longer leg is the positive lead, while the shorter leg is negative. I'm going to place the longer leg of the LED to the positive end of the battery. Notice the plus symbol, and the shorter leg on the negative end. In other words, positive to positive and negative to negative. When the legs are pressed against the battery, the circuit is closed and the LED will light. Now if the LED works, but you've reversed the legs, the LED simply won't light. This coin cell battery produces 3 volts. It provides enough voltage to light the LED. It also supplies a small amount of current. The LED can handle the amount of current from this battery without needing a resistor. This second test checks whether both resistor and LED are working. and I'm going to use a mini breadboard to connect the parts. I did not need a resistor in the previous test because the battery source was small and supplied less current to the LED, but there is a direct relationship between voltage and current. When one increases, so does the other. So when voltage goes up, current goes up. When voltage goes down, current goes down. Notice the battery source is much larger in this test. These are 4 AA batteries that deliver approximately 6 volts. This means it supplies more voltage, therefore it will supply more current. If a resistor is not installed to limit the amount of current passing through the LED will draw more current than it can handle and it will burn out. The cool thing about resistors is, they don't have polarity. This means they are reversible, and I don't have to locate a positive or negative lead, or worry about which direction it is placed in the circuit. I can also place it anywhere between the battery and the LED. In this case, I am placing it between the battery and the short leg, in other words, the negative lead. Now, let's get to the fun stuff. I'm going to wrap the resistor around the short leg of the LED. This is the LED's negative lead. I'm going to use my needle nose pliers to pinch the wires and to make a tighter wrap. This may take a couple of tries. Next, I'm going to use my favorite wire stripper to strip the wire off both ends of the hookup wire. These are self-adjusting wire strippers. It can strip many different sizes of wire and can strip multiple wires at the same time. It also allows you to adjust the tool to strip the same amount of insulation off your wire, giving identical cuts each time. Take the red hookup wire and wrap it around the long leg of the LED, the positive end. The resistor is already wrapped around the short leg of the LED, the negative lead, so take the blue wire and wrap it around the end of the resistor. Use some wire cutters to trim down any remaining length of the resistor's leg. You can also use the wire cutters or pliers to manipulate the resistor's leg, like I'm doing here to make a hook. Be delicate when sliding on the heat shrink, because there isn't any solder holding on the wrapped wires. Slide the heat shrink over the wrapped wires. The goal is to slide the heat shrink as close to the base of the LED light and cover any exposed metal along the legs of the wrapped wires. This will help in 2 ways. 1, the heat shrink will act as a barrier. It will prevent the positive and negative leads from touching and creating a short circuit. 2, it will hold the wrapped wires in place after you apply heat to the heat shrink. I had some trouble with this red wire. The red color-coded heat shrink is smaller than the blue one, and the stranded copper wire at the end of the red wire stripping is catching the heat shrink, which is preventing me from being able to slide the heat shrink onto the wire. I'm speeding up the video for this heat shrink section, so movements might seem a bit faster during this section. Heat shrink requires heat, so I'm going to use a soldering mat. It's made of silicone and is rated to handle high temperatures. I'm also using a heat gun to apply heat, but I've also seen videos of people using a lighter to apply heat and shrink the tubing. This is a special type of heat shrink. It's a solderless wire connector, also called a solder seal wire connector. It allows you to splice wires without applying solder to the wires first. This material can get hot and somewhat sticky, so do your best to keep your fingers away from the tubing until it has cooled. The main thing to remember is to move the heat source back and forth to apply heat evenly across the entire tube. Also, rotate the tube to apply heat to all sides. Now, take the red wire from your battery source. This is the positive terminal. Insert the red wire into one of the Wago wire splicers. After clamping the lever down, give the wire a good tug. It should be securely fastened. Now, take the black wire from your battery source, the negative terminal, and insert it into the other Wago connector. Take the red wire attached to your LED and insert it into the Wago connector set up for positive connections. Then, take the blue wire and insert it into the Wago connector set up for negative connections. At this point, you should be able to turn the LED on. Grab your action figure and place your wire connection into your action figure's hand. I'm not going to use this hot glue gun because I'll use this battery case for other projects, but you can glue your action figure's foot to your case. But if this were me, I'd probably use something like Velcro tape instead of a hot glue gun. This way, the toy can still be played with when the nightlight is not in use, or switched out with other nightlight action figures.